Morning to all. It's indeed a great pleasure to stand before you today on behalf of St.Ann's College of Education and represent the college regarding the virtual classrooms. Due to immense change in the technology and great developments in the field of ICT, we have been exposed to various methods, techniques and approaches in the classrooms. So, one such method we are here putting forth before you is teaching a lesson in geometry in 8th class, exploring geometrical figures through our ICT based lessons. All of you are welcome. Geometry is one of the ancient branches of mathematics, and Euclid of Alexandria has given scope for exploring geometry in n number of ways. Shall we today explore or try to even understand how is that a human mind works towards exploring geometry which is around us, first of all, and in us and in the nature and in the world. We will just make an effort to see how beautiful the world is and what are the things, what are the basic principles of planar geometry, what the great Euclid has promoted to make us understand the geometrical figures, shapes, their characteristics, their features, their shape, their size, and how does it play a very important role in our daily lives. Have you ever, all of you are used to patterns in life. Now, this looks beautiful, but have you ever thought about it that this has got a structure, this has got a basic principle behind it? Please think about it. Now, whenever a festive mood comes, whenever there is a festival in our house, the first thing what we do is look around how to decorate the house, how to decorate the walls, how to decorate yourself too, right? Now, you go to the shops to buy the best of the designer sarees. You go to the beauty parlor to make over and transform you from what you are to what you can become more beautiful, right? So, these are all aspects of geometry which normally people won't recognize as mathematics, and that is what an 8th class child always asks the teacher, why are you teaching this to us? What's the purpose of learning all these things when we don't use it or see it around us? Now, this is a piece of Rangoli designs, and designs just does not happen like that. It happens with a purpose, it happens with a shape, it happens with a size, it starts happening with a point, what Euclid has talked about. Because when there is a point here and if it is stagnated over there, then nothing can happen in this world. Now, if I am going to lecture like this to you, damn boring it will be for you. So, there is a kind of translation needed from there to here. But did I change? I am the same person, isn't it? I have not changed. My characteristics have not changed. So, it is only the place from where I am in the alpha plane. I have been moving from the alpha plane in the same alpha plane to a small distance from there to here. That is what I did. But what happened here? I can still hold a point here where that point and this point can get connected. So, when things get connected together, it either results in a beautiful shape, not necessarily always it is beautiful, it can be regular, it can be irregular kind of shapes. So, when you purposefully want a regular figure, there is a process of creating patterns, regular patterns. Now, I did talk to you about going for shopping, and you look for beautiful designs, or nowadays it is fashion that you want a particular design to be imprinted in your, either in your sari or your dress, or on your blouses, because that's what is called as designer blouses. So now who designs it? All those who are designing there, are all of them mathematicians? No, I don't think so. But they would have learned the rudiments of mathematics from their childhood, so that they got that particular skill. Something is embedded, something is created. So aren't we as teachers responsible for creating that aesthetic aptitude in each and every child? Please question yourself. Now, when we look for patterns, we do have wonderful patterns. Everybody has got their own creativity to create patterns. Look at this piece of art. Now it's finished. It's a finished product of art. Now, do you see beauty in this? Do you see symmetry in this? Do you see congruency in this? These are the basic rudiment principles of geometry, which Euclid had thought about it in BC, not even now. Now, I will turn the page and show you how this could have been created. What do you observe here? You observe only half of the pattern onto the left hand side or to your right hand side, whatever it is, but it is only completed half the way. Now, if I give this piece to you, won't you be able to complete the other half? Perhaps. You may need a graph sheet, usage of graph sheet for this particular aspect, where suppose we put this onto the graph sheet and take a printout or trace it onto the graph sheet, and then with exact calculations of how many squares it occupies, we try to complete the other half. Don't you become artist? See, this is the way geometry helps anybody to even become a perfect artist, even though you are not good at drawing. I am also not good at drawing, but still you can try to become a good artist. This is called the reflection symmetry, because there is a line over here where you can see, where from that particular line, it is the imagination of the child which has to run through here to copy the other half onto the other side of the paper. Don't you think that we all can create patterns like this? So, this is one instance where I would like to talk to you. Now, coming to this is what you see here, where this is a graph sheet, and how this particular diagram, you can call it a diagram, you can call it an art piece of art, you can call this as a pattern, you can call this as a print on the sari or kurti. It varies as what you want to use of this particular art piece. Now, it is scaled. Now, it is scaled. As I have shown it on the graph sheet, this is scaled now. Now, it has come to a perfect x axis and y axis coordinate axis, where there are numbers, horizontal numbers and vertical numbers, and this particular pattern is scaled down here, where when you look at it at the back, now you see that it is only one half which is printed over there, and the other half could be drawn, may not be perfect, but still it can be reproduced with your intelligence, your creativity and your interest. Perhaps this is what educators call it as HOLs, higher order learnings, or maybe development of metacognitive abilities. Now, one such pattern here is this. You can see how a sari designer or a designer would turn the particular pattern, because nobody likes monotony. Right? Every time you put square pieces, every time you put circular pieces, and it's quite not assuming to the eyes or to the mind, or it is not, you don't get any feeling seeing that. They turn it, they tilt it, they move it, right. So, there are changes, do not you see changes from the first block to the second block to the third block to the fourth block to the fifth block? Yes, right. What is the change? So, on what basic geometrical principles are these turning happening, or the spacing happening, or the changes from one place to the other place happening? Now, if I put it like this, that becomes another pattern. Now, if I put it like this, that becomes another pattern, and people who buy, they think that, oh, wonderful piece of architecture, a wonderful creator who has created this piece of artwork. So, this is how we explore geometrical figures around us. Now, shapes and sizes you see around you always. Now, there are shapes and sizes which are sometimes congruent. Suppose I say a namaste to you, right. Now, you see that all my fingers are superimposed. My left hand is superimposed on the right hand, either this way or this way or this way, right. Now, it is superimposed on each other. If I little tilt it, both the hands are similar, but you do not call it the principle of congruency. It is similar to my right palm. It is only similar, they are not congruent unless they are superimposed on one another. Now, abracadabra, let us explore opening this piece of artifact which is before you. I am just opening it, keep watching, keep watching. What is that which is finally produced? It was superimposed on one another. I will close it again. 2, 3, 4. So, it is a square piece, right, which was superimposed on one another. And what is the principle which has happened here? This is getting translated over the same plane, alpha plane. Again, this is getting translated over the same alpha plane. This particular piece is also getting translated over the plane, same plane, and this is also getting translated before this plane. Now, we know there are terminologies which have been from the beginning using, like translation, transformation, right. Are they all same? See, this is where mathematics should be taught in combination with English methodology teachers, because language plays a predominant role in teaching of mathematics. Now, this is translation. Now, when I put the pieces like this, suppose I put the pieces like this, the same piece is getting transformed. So, are they the same? Translation and transformation? I do not think so. I hope you have got the meaning correctly, that translation is movement of the body in the same plane. Now, when you derive or evolve at something else which is not what it was before, even though the shape and the size and the angles are same, finally the byproduct is not the same, right. It has become from 2D to 3D. Now, when it becomes from 2D to 3D, it loses its 2D characteristics. 2D matlab two-dimensional characteristics. Now, when it loses its 2D characteristics and becomes a 3D figure, it is getting transformed. It is not translated. So, there are terminologies which are there in the text which look similar, and that is why SERT now is insisting on reading of the text and then discuss the certain terminologies which look similar, which look synonymous, but they differ in their meaning. Now, look at this phenomena, what is happening here. Look at this exercise which is happening here, right. This is getting superimposed on one another. Now, are they all of equal size and shape? Yes, they are all of equal size and shape. Now, when they are superimposed on one another, what is the principle which is formed there? Now, is it Is this translation or transformation? Is it for you to explore now? That is how you explore geometrical figures. Because if now when I am, I hope you saw the movement. If I am moving it on the plane like this, this becomes translation. Now, when I am superimposing one on the other, it becomes transformation, because that poor square which had 2D characteristics lost its characteristics, and add-on characteristics has come, thickness. There is add-on characteristics here which has been evolved, that is called thickness or the height, whatever the child wants to name, the child can name. That is where the teacher has to allow the child to use whatever terminologies the child knows in his prior learning experiences. Now, coming to this particular piece where we see, now look at these scalene triangles. Why do we call this scalene triangles? Because all the three sides are not equal, right? But it is clearly demarcated with colors, so that when I superimpose one on the other, you can see that the red lines are coinciding with the red, blue is coinciding with the blue, the green is coinciding with the green, isn't it? Now, when I move it on the same plane, it is still on the alpha plane. Whether it is alpha or beta or gamma, that is what Greek people used to denote the plane as. Now, when I move it on the same plane, it is getting translated. It is taking a different position as I move from this side, or I move from one side to another side. Now, I am not these are similar figures, right. Now, when I put one upon the other, the same figure is getting transformed. The same triangle is getting transformed. Now, suppose I take two pieces. Yeah. Please observe the action. Right? I neither translated nor I transformed. Of course, it is looking transformed. Maybe it is looking ugly to you because it does not have color, but it is still the same person over here. It is still the scalene triangle which has been ulta, which has been on the other side, right. This process is known as flipping. This process in geometry is called as flipping. Now, consider this as a mirror. Consider this particular scale as a mirror. Now, do you find any principle here? You should, because you always stand before the mirror to see yourself, no? Not realizing that your left is their right is my left, right. Now, if this is a mirror, flipping always happens across the line. Please note this point. The process of flipping always happens across the line, because it was on this and I just flipped. Now, you know that you toss a coin, you know that you flip a coin. Now, suppose you get, flipping has another meaning in English, go mad, right. So, suppose you get annoyed with your servant for not cooking food properly, you flip the plate, do not do it, that is not a good habit, right. But then you flip that means you are not at your peace, right. So, flipping happens across the line of demarcation. There is a line of demarcation here, there is a line of line dividing here. Now, look at these properties. When once it is flipped, this becomes the image, this becomes the object. Now, there is one more property here. What you have to understand is, when we flip, right, what are the activities what you have seen? One is sliding, right. You can even turn this, suppose this is the baseline, I will put it here, right. We can turn this, right. It will not look as a regular figure because it is a scalene triangle. Suppose I turn this, now see the difference. I am going to turn this. Was there a difference? No. Again I turn this. Was there a difference? No. Again I turn this. Was there a difference? No. Because this is a square where all the sides are equal and all the angles are equal. So, you know, wherever, whichever form you turn 1, 1/4, turn 2, half, turn 3, 3/4, turn 4, full turn. It has come back to its original position what it was here. It is not flipping, it is turning. So, when a square turns, it takes the order of turn is 4. The order of turn is 4, and when does the order happen? That shows that a piece of square has got rotational symmetry. This piece has got rotational symmetry, whereas this piece does not possess a rotational symmetry. Nothing wrong with this piece. This is how our children are treated in the classrooms. One is a square piece and one is a scalene triangle piece. And you expect the scalene triangle piece to perform like square piece. How can that happen? Right? So, there are messages which comes from inanimate object also for you, but we do not take care of that. That is where, you know, this has got its own unique property. Later you will come to know that this particular unique property may produce more beautiful art pieces than this, because this is monotony sometimes. After some time, you know, square remains square, but this can be rotated. You know, you draw a line here, then you turn it, draw a line here, you turn it, you draw a line here, you turn it, you draw a line here, and find out what is that finally happening over there in that particular piece of paper. You may find a better pattern than turning a square piece, right. So, that is what the difference is here. So, now what are the things what we have learned so far? We just because I have been talking for a long time, let us see that what are the elements what we have discussed so far. Shapes are said to be congruent, shapes are said to be congruent if they have the same shape and same size. Shapes are said to be similar, shapes are said to be similar if they have the same shape but not the same size, because the sides are different here. So, these two things we have clearly understood, which is the basic fundamental principles of Euclidean geometry to create patterns in life. So, this particular thing we have crossed.